Go.
Oh, special
Okay.
right triangles.
Special right triangles. Fun.
Yeah.
No, this is a topic that we're going to need for every math class after this. So important topic. So first we're going to start off, there's two special right triangles. The first one we call 45, 45, 90. Where do we go to 45, 45, 90? From
90.
a square. So start with a square, and we're going to draw a diagonal that is already there.
Yeah.
Hey, I like the confidence.
Right?
That's
So
90 degrees.
it is 90.
Oh.
Okay, so both of these they're called special right triangles because they have a
90 degrees.
90-degree angle, okay?
Well, and they also have 245 degrees.
And they both have two 45-degree angles because the sides are congruent, right? So the base angles have to be congruent.
Sure.
Okay, so if each side is
So
just
isosceles.
one unit, yes, isosceles right triangle.
So it's just a square since it has.
Okay, we start with the square,
Yeah,
and we
to me,
cut
the
it
dotted
in half
line doesn't
diagonally.
exist. Unless it's like a full line, it exists. Like, why is it dotted?
Evan doesn't like it when it's not dotted, but when it's not
Go ahead and make it a solid line then.
Oh.
Okay, 1 squared plus 1 squared equals x squared because this is Pythagorean theorem. So this is just going to be 2. And so what do? We take this.
1.7?
Well, we're going to leave this.
1.3.
It is one. No, it's 1.41.
Oh,
But we're going to leave it
star.
as just the square root of 2.
Max.
Okay.
Max.
Yeah.
Remember the thing we learned last year where you had the graph with like a dotted line or like a straight line?
Yeah.
What was
Inequalities.
That was inequality.
Okay, moving on. So our theorem says in a 45, 45, 90 triangle, the hypotenuse is always square root of 2 times the length of the leg. So if we look at that last picture, if this is 1 and this is 1, this is 1 times root 2. If this was 3 and this was 3, this would be 3 root 2.
So
Understandable.
Oh, wait, do that again.
Yeah, that makes sense. That makes sense.
So if this was
Right.
3 and this was 3, this would be 3 root 2.
Because that's 1 root
So
2.
do we even need the Pythagorean theorem anymore?
No,
We just
that's
use
the
this?
objective
No,
of-
because Liam, this is only for special
that's
rectangles.
so
Oh my
cool.
god, it's genius.
This only applies.
This is so good.
This only applies if you have a 45, 45, 90 triangle.
Keep making
So we still need the Pythagorean theorem.
Okay, so if you know what the leg is, you multiply by square root of 2 to find the hypotenuse. What if you have the hypotenuse and we're trying to figure out what the leg is?
Just reverse it.
It just reverse it. So you're just going to have the hypotenuse divided by the square root of 2. Now keep in mind,
Wait, what? How do you divide the square root? Oh. Okay.
Right?
Wait, no.
So it's
Wait, the hypotenuse, is it x times root 2 or just root 2?
okay, listen, I'm trying to give you in general. The hypotenuse is always going to be square root of 2 times the leg. So what if I wanted to solve for the leg? I would divide both sides by root 2. So hypotenuse divided by root 2.
Yeah.
Yeah, that's it. Okay, find the exact values. See, this is why I say we don't want to turn it into a decimal. So first of all, these are congruent. So x has to be 5. And then y is 5 root 2.
Whoa.
Why is it root 2?
because that's part of the theorem. That's part of
Directly
the theorem.
above
It's
it,
a
the last
proportion.
theorem.
It's just always root 2.
With a 45, 45, 90 triangle, it's always times root 2. Now, this time, I gave you the hypotenuse. So, remember, the leg is going to be the hypotenuse divided by root 2.
So 20.
So I'm going to have 20 over root 2, but I don't want to leave it like
So
this.
you multiply by root 2.
Good. We're going to multiply by root 2 over root 2. That gives us 20 root 2 over 2.
You can
Wait,
simplify
this
that
is
so it's
above
10
it
root
says
2,
the
right?
hypotenuse is the root 2 times the leg. Oh, never mind.
Listen, if the hypotenuse is given, you have to divide by root 2 to find the leg.
Doesn't
If I have
x
the
equal
leg-
10 root 2?
Can you like divide the 20 into 2? Like,
Yeah.
Okay, so there is a shortcut.
I did
So
it a different way than
if you have 20 divided by root 2,
oh.
we'll
Yeah.
always get 10 root 2. If I had this was 14,
7.
it would be 7 root 2.
So it's just half.
It's, oh yeah, if this was 8 root 2, or sorry, 8, I would get 4 root 2. Okay? And again, y is the same thing, so they're both 10 root 2.
Cool.
Oh, that's cool.
Is there a right triangle that's 50, 40, 90?
There is, but there's no rule about it.
Ray Allen. Reggie Miller.
Kyrie.
Okay, 30, 60, 90. So in this one, I'm starting with an equilateral triangle. And this time, I want to draw the altitude.
They're all equal.
So I'm giving you an equilateral triangle where 2 are all the sides. You can make it whatever you want. You'll see why I make it 2 in a moment.
It's not also equal.
So if I draw the altitude, that makes a right angle. And in an equilateral triangle, all the angles are 60 degrees. So what
30.
happens at the top, that angle
30, 30.
is 30. Okay, now, the altitude also bisects the side. So if the whole thing on the bottom is 2,
So it's 1 each side.
so we have 1.
Yeah.
So what's the relationship between the side opposite 30 and the side opposite 90? What's always going to be true?
Oh,
It's
because
always going to be half, right? So if I had a hypotenuse of 10, the side opposite 30 would be 5. Okay, so this shorter side, the one opposite 30, is always half of the hypotenuse.
oh,
Now, what if we wanted to find the one opposite the 60 degree? We could do Pythagorean theorem. So let's see, 1x squared plus 1 squared equals 2 squared. So x squared equals 3. We take the square root. So x equals root 3. Okay, so look at what we have. The shorter, we call this the shorter leg. This is what we call the longer leg. And here we have our hypotenuse. Again, we're just looking at half of that equilateral triangle. So anytime we have the shorter leg, we're going to multiply by root 3 this time. If we want to find the hypotenuse and we have this leg, we're going to multiply by 2. So here's our theorem. Okay, in a 30, 60, 90, hypotenuse is twice the length of the shorter leg, and the length of the longer leg is root 3 times the shorter leg. So this is what it looks like here, here, and here. So if we know the shorter, I call it shorter leg because it's opposite the 30, right? And the longer leg, so this is the shorter leg. This is the longer leg. And obviously here we have our hypotenuse. Okay. That means, again, these are shortcuts, so you don't have to do Pythagorean theorem. This homework assignment is not supposed to have a lot of work in it. You're supposed to apply these theorems. So if I gave you a hypotenuse, let's say I gave you a hypotenuse that was, oh, I don't know, let's say it was 16. If this was 16, what would the shorter leg be? 8. And then the longer leg would be? 8 root 3. So if this is 16, this would be 8. This would be 8 root 3.
If what?
I just gave you an example if it's 16. So if you have one side, you can figure out the other 2 sides. Remember, Pythagorean theorem, you have to have 2 sides in order to find the third. What makes these unique is you only need to know one side. Okay, so again here, hypotenuse is 2 times shorter leg, longer leg is root 3 times shorter leg. Okay, so first thing you want to do is which side did I give you? The shorter one. I gave you the shorter one.
So X is 20.
Well,
X,
y is
no,
the hypotenuse. So
Y is 20. X,
y is 20,
X is 10 root 3.
10 root 3. Because 20 is the height. Remember, it's always the shorter leg and the hypotenuse that have a ratio of 1 to 2. And then this you just do times root 3.
What if I only have the long side, the second?
Okay, so I have the hypotenuse.
Is y
Which
like,
one is the shorter leg? X or Y?
Y.
Y.
Is y like 2 rad 3?
Okay, so hold on. What's the relationship between the hypotenuse and the... So the shorter leg,
And then X is 6.
so if the hypotenuse is 2 times the shorter leg,
This one's divided by 2?
I gave you 4 root 3.
Or 3 over 2?
Right, so
It's
Should be
2.
2 root
it's
3.
got to be 2 root 3. Good. Okay, now how do I find x? What do I have to multiply the shorter leg by?
Minus root 3.
By root 3. So x is going to be 2 root 3 times another root 3.
18. What?
Okay, what's root
Root
3
three
times
times
root 3?
3.
3. What's 2 times 3?
Oh.
6.
Okay, I get it.
If a y is a times root 3.
Because
'Cause-
the longer side is root 3 times the length of the shorter.
Oh, okay.
That's yeah. Okay. You just have to memorize those. Okay. All right. C, this is a 45, 45, 90. So now we're going back to the first theorem. What's x and what's y?
I already forgot the first theorem.
Okay, well, first thing, if it's 45, 45, 90, 2 sides have to be the same. The 2 legs have to be equal, right? So y has to be 5 root 2. Here's how I try to remember 45, 45, 90 has 2 sides that are the same, so that's the one that you multiply by root 2. 45, 45, 90, 2 sides the same, root 2. 30, 60, 90, I just remember 30 is what we start with, so root 3.
Why would y equals square root 2 again?
What kind of triangle is it?
Oh, okay.
Okay, so what are we going to multiply by root 2? So that gives us 10.
Wait, times root 2. Oh, okay.
Right? Okay. What side did I give you in the next one? And this is a 30, 60, 90. This is the hypotenuse. So x has to be half of that. So x has to be 49. And then y has to be, good. What do you think?
Oh, wait.
Oh. Okay, so now some word problems, but still just applying those same 2 theorems. Okay, so we have the perimeter of an equilateral triangle is 18. Find the length of the altitude of the triangle, and we want to write the exact answer. So meaning, whenever you see exact answer, that means we want to leave the square root. Okay, if the perimeter is 18, what is each side? 6. And we said this was equilateral. So we're going to draw the altitude, and that's going to make what kind of triangle?
30, 60, 90.
A 30, 60, 90. Now,
Shorter side is 3.
shorter, oh, I just realized I put 30 twice. So this has to be 3. So what's the altitude? 3 root 3. And, right, because it's the shorter leg times root 3.
The altitude is root 3?
3 root 3.
Okay,
So-
yeah, I get it.
No, I know.
No, you know?
No, I know the answer. But why times root 3?
Because it's the longer leg. We take the shorter leg times root 3 to find this one.
The longer leg.
Yeah. Okay, diagonal of a square is 10 centimeters. We want to find the perimeter, and we want to write it in the exact
So this is
form.
a 90.
So this is a 45, 45, 90. So how do I find the sides of the square? If I have the hypotenuse, how do I find the leg?
Over 2. Over
Over,
round 2.
so we're going to take 10 divided by root 2, and that's going to end up giving us
5 root 2.
good. And so now the perimeter, it's a square, so all the sides have to be the same. So 4 times 5 root 2.
It's just 5 root 2 or whatever.
Each side, yeah. Because I showed the rationalization. All you have to do is divide the top by 2, and then
What about like?
aren't all the sides the same though? Doesn't matter which one I do. So 20 root 2 for the perimeter. And there were units this time, centimeters. Good. Last one. And then I'll give you the worksheet for homework and the practice quiz. Okay. You want to try this one on your own? Bless. So we have an equilateral triangle. Altitude is 5 root 2. Find the length of each side of the triangle and then find the area. What do you think? Give it a try. Alright, stuff already? This one has a little bit of a trick because there's already a radical and we have to.
Yeah, it's divided by radical by root 3, right?
Yeah, you got to divide it by root 3. So I think you might have like a root 6 in your answer.
Yes. Oh, okay. It's not like the other one where you just cancel off the square root.
Well, is it the same square root though? One is a square root of 2, one that is a square root of 3.
Wouldn't it be times root 3?
No, because it's the longer. If you had the shorter leg, you would multiply by root 3.
Oh.
Everybody get the answer yet?
Each length
I
of
found
the
the length,
sides.
yeah.
Okay, so now, how do you find area of a triangle?
So
Base
times
times
5
height.
divided by 2.
Perfect.
Oh, so isn't it 60 root 6?
I don't know. What do you guys get?
So should I use
What would you
the
have?
base of the entire
The whole
equilateral
base.
triangle or up
Just for one.
or up
What is the leg or like the whole thing? Like 10 root 6.
10 root 6? Let's see. So did you take, just to figure out this, would be 5 root
Right, you
2.
multiply once you get there.
And then you got to multiply by root 3 over root 3.
I did the opposite of what you did.
Okay.
I do it a whole different way than you when I get the same answer.
So,
where did the 10 come from? What? Yeah, what is
So
oh, sorry, that should be a 5. I don't know. I was jumping ahead to the 5 root 6 over 3.
Oh,
And then what's the length of each side? That's going to be 10 root 6,
wait, so just that
Over
small
3.
part is 5 root 6 over 3 or the whole thing?
just this half.
why is it over 3?
So each side is 10 root 6 over 3. You have a root 3 on the bottom, so you have to do root 3 over root 3.
You say the second and third.
And then finding the area, you have 1/2 times the base.
I don't have a root 3.
You don't have a root 3? Why not?
I don't have an over 3.
You have to,
How?
because it's a 30, 60, 90.
Does that
Well,
equation
that
for the
thing
area
is
only
5
find
root
the
2.
area for a right triangle? Because what if it asks for the area of the entire equilateral?
We are doing the entire area of the equalateral triangle.
Oh, you're
Because
just gonna
if this is 5 root 6 over 3, what's the whole base? 10 root 6 over 3
Yeah.
times the height. And then you could do divide by 2. The reason I just put a half in
This
is
case is.
because I'm dealing with fractions
What if
already.
you do 5 root 2 equals x root 3?
Yeah, Then you divide by root 3.
Wait, can you do that on the board? 'Cause I
Yeah, let me just finish this. Let's see. 25 root 12 over 3. Because you have 10 times 5, so that divided by 2, that would be 50 with a 3 on the bottom. And then root 6 times root 2. Can that be simplified further? Can square root of 12 be broken down? Yes. So I'm going to rewrite this as 2 root 3. So we get 50 root 3 over 3 for the area.
Wait, why is each side 10 root 6?
What happened to the half? Oh,
But to find the area, don't you need the base times the height?
Hold on, let me just pause this.